Lawrence Berkeley National Laboratory. Dr. Simon joined the laboratory in early 1996 as a director of the National Energy Research Science Computing Center, and under his leadership, the center enabled important discoveries for research in fields ranging from global climate modeling to astrophysics. Dr. Simon is an internationally recognized expert in computer science and applied mathematics, and he received the Gordon Bell Prize for Parallel Processing Research twice, first in 1988 and again in 2009. He was also a member of the team that developed NASA's Advanced Supercomputing Parallel Benchmarks, a widely used standard for evaluating the performance of massively parallel computing systems. Dr. Simons holds an undergraduate degree in mathematics and a PhD in mathematics from the University of California at Berkeley, clearly a great university given how close it is to the 15th Congressional District. I also should personally note that during my last visit to Lawrence Berkeley Laboratory, as I was nearing the end of the tour and had to go to another meeting, Dr. Simon had the unfortunate distinction of drawing the shortest straw, and his presentation was at the very end, and he was following me all the way out to the parking lot. He was so excited about the research and what he was working on that I'm happy to continue listening to you, Dr. Simon, by inviting you here to testify today in Congress, and I really appreciate the work you do for the Bay Area and the international science community. Thank you, and I yield back.
Chairwoman Loomis, Ranking Member Swalwell, and distinguished members of the subcommittee. Thank you for holding this important hearing and for inviting me to participate. I'd like to deviate from my script very slightly and mention that I'm a co-author of the Top 500 list, so if there are specific questions on ranking supercomputers, I'd be very happy to answer these questions. As I was introduced, my name is Horst Simon. I'm the Deputy Director of Lawrence Berkeley National Laboratory, a multi-program Department of Energy Office of Science laboratory managed by the University of California. Berkeley Lab has a very long and distinguished history of producing world-leading science, and today continues to be an international leader in many scientific fields and technology areas, from the mysteries of the universe to delivering new energy solutions. Considering the challenges that our nation is facing, there are few issues that are as critical to the nation's well-being as the vitality and productiveness of our innovation ecosystem. We do have a national ecosystem that is comprised out of universities, the national labs, and of course industry. And it's the interplay of these three components that make us so competitive and make us very unique. In my daily work, I encounter almost every week visitors from around the world, from Asia, from Europe, who come and visit the national labs and want to find out, how does a national lab work? How do we interact with industry? How do we interact with universities? Because that system is very difficult to build and difficult to replicate. All three pieces of the system, universities, industry, and national labs, are equally important and need to be supported. In my comments, I would like to focus on what the national labs do. There are three important contributions that the national labs make. One, as it has been mentioned already by my colleague, Dr. Dehmer, we operate large-scale scientific facilities. These are facilities that are unique, very large, very difficult to build, difficult to maintain and operate, and that require consistent support over many years. These facilities are unique, not just in the nation, but worldwide. They provide a tool for our scientists to engage in really innovative, new basic science and advance our state of knowledge. The second element is large-scale, multidisciplinary team science. Many of the challenges that we're facing today require the approaches that combine the input from very different disciplines. One example that was mentioned are about the bio-research centers. For example, the J-Bay Research Center in Berkeley involves scientists that have background in agriculture, that have backgrounds in chemical engineering, and that have backgrounds in biology. They work on a very challenging problem that will take many years to resolve, that is getting from cellulosic matter to biofuels. Bringing all of them together and solving on these large, challenging projects is a characteristic of the national labs. Third, I'd like to point out that the national labs have a very important element of education to do. We are supporting, for example, in Berkeley, close to 900 postdocs and graduate students. These are individuals who come through the National Lab on an ongoing basis. We actually have each year of the order of several hundred students that spend some time at the lab. The labs have are an important element for training and educating these students because they learn what the real problems are that the nation is facing and how the tools of science can be brought to bear on solving these problems. Even if they don't stay in the national lab system, they move on and become either academicians or work in industry and contribute to our innovative national ecosystem. So all three elements are equally important. I would like to conclude my testimony with a very personal comment. I came to the United States in the 1970s as a graduate student from Germany, and I received my PhD in 1982 in Berkeley. I had not planned to really stay here, but being a graduate student in one of the top universities, I found out very quickly that for a scientific career, the United States is the best place to be. I had spent some time in universities and industry and then came back to the national labs in 1995 and had a very, very productive career. I became a citizen a long time ago and very much enjoyed the support that you are providing to scientists like me that advanced my career, and I have hopefully contributed significantly to the American innovation ecosystem. The unfortunate statement that I have to make at the end of my testimony is that if I were to meet myself today, a graduate student getting a PhD in 2013, I'm not sure if I could tell him or her the same thing that was true 30 years ago. It's not clear to me that this country has all the tools in place to provide an environment to be a productive environment for scientific inquiry. Thank you.